discuss now in next half an hour is Python variables, or Python basically two data structures. One is integer and one is real. Okay. Now I'll go a bit deeper. I mean, just to see how the numbers are stored and so on. That's for completeness. As a Python user, you don't need all that information, but it's good to know this information. How numbers are stored, what is called round off error. So you'll see that in the coming discussion. So there, Python has several types of variables. One is integer, other one is float or real. Okay, float is same as real. I'm gonna tell you the why it is called float. But you give me another 15 minutes. A third is string. This for characters. Okay, like your name is a string. And Python has a very powerful way of dealing with strings. Then called list. The one I had typed, 1, 2, 3, 4, 5. That is called list. List is a list of numbers or list. In fact, it could be inhomogeneous. A list could have 1, Mahindra, IT. So it can have inhomogeneous elements and arrays. Okay, arrays are real numbers. So all the numbers are either integer or real. It can't be mixed. Okay, so what we'll work with is arrays in this course. Of course, we'll work with a little bit with list and string and so on, but essentially we work with integer, float, and arrays. Now let's look at integers. Binary. So basically, computers store numbers in binary format, so they don't understand decimal, okay? Because the digits are either 0 or 1. For us, we work with 10 digits. Now, why 10 digits? I mean, it's a curiosity. It's not clear why humans work with the binary decimal, but possibly this 10 fingers would have been one reason why we work with decimal. This bit of mixing has happened here. Okay, so actually, ignore this 111 something sitting there. So the number is 101. Okay, right now 101 here in this figure. Now 101 is exactly a decimal. No? So 1 has power 2 to the power 0. This is multiplied by 2 to the power 1. Like in decimal, we would multiply by 10, right? And here this multiplied by 100 in decimal, but here multiplied by 2 squared. So this 2 to the power 0, like 2 to the power 0 times 1, 2 to the power 1 times 0, and 2 squared times 1. Okay, so you just multiply by the weightage depending on the position. So what is the position? This is 0th position, 1 position, 2 position, and that's how this power is coming. Now this is just exactly like decimal. Okay, so all these are, so your representation can be different system, but the number is the same. Okay, now 101 I can convert it to decimal by this operation. 1 times 2 to the power 0 will be 1. This is 0, and this is 4 times 1 is 4, right? So you multiply this by 1, multiply this by 2, and this multiply this by 4. So the number is 5. 101 is 5. Okay. Now we can have more digits, like in a byte, I can have all this digit. So how do I convert it? I mean, of course, I have to multiply like that. 2 to the power 0, 2 to the power 1, this 2 to the power 7. Now it's too clumsy, I'll have 8 multiplication and addition. So we can also work with hexadecimal. Okay. Now hexadecimal has digits 0 to 15. Okay, not 0 to 9. 0 to hex is 16. Okay, so 0 to 15 is the digit, but 15 how will I represent? I don't represent by 1, 5. Okay, 15 is F. So 10 is A, 11 is B, 12 is C, D, E, F. So these are the 6 digits, A, B, C, D, E, F. They go from 10 to 15. So this 111 is 15, that is F, and this is 1 plus 2 is 3 plus 8 is 11. 11 is B. Okay, so FB, this number in hex is 16. So this is called base. So 16, base 16 is FB. Now, how do I convert that to decimal? I multiply, well, B remains as is, which is 11. But f is, remember, f is 15. I multiplied by 16, right? So 16 is the base. So 16 power 1. If I had number c to the left, then I multiply that by 256, which is 16 squared. Now this is trivial. You can just look at my notes where I detail it a bit more. That's for pedagogy sake. But I mean, if you're interested, you can read all of that. Now this number is 251, right? Because 15 times 16 is 240 plus 11 is 251. So this number in decimal base 10 is 251. So you can convert one from the other. Now we can also, I mean, you can easily see, well, there's another base system called 8 octal. Okay, that's also used. So 373 in octal is 251 in decimal. Because why? 3 plus 7 times 8. Oh, I'm sorry. This is 8 squared, 8 squared, not 82, 8 squared. So 3 times 64. If you add these together, it's 251. Now, in Python, it's allowed to, I mean, you can get the equivalent representations. So I write x equal to 100. So if I write x equal to 100, 100 is not binary. This is decimal. So Python will talk to in decimal. But you want a binary equivalent, then I say bin x. Bin x. So it will give a number 1100100. Okay. Now 0b, this is called binary. 0b is binary. Okay. Now, so this is my binary representation. You can just check yourself that this will give you 100. If you want octal representation, say oct x. So this 0o and 144. So in octal, this is 144. I can easily check that one. 4 plus 8 into 4 is 32. And 1 into 64 is 64. So 64 plus 32 plus 4 is 100. Okay. In hex is 64. Okay. 6 times 16 is 96 plus 4 is 100. Okay. Anyway, these are useful if you are debugging your code and things like that. But it's also good mathematics. I mean, simple mathematics, school mathematics, but it's kind of attractive. Now in Python, integers can be of any length, as I said before. I can really have very big integer if you need. Now integer operations, there are power operation, star star. Okay. Now multiplication is star. Integer division is double slash, not a single slash. So 5 double slash 3 will be 1. Okay. 5 slash 3 is 1.66666, then 7 at the end. Okay. So this you need to remember. Okay. Integer division is double slash. Modulo is percentage, and of course plus minus, you know. Now if you have complex, I mean, if you have more operators, then sometimes you need to define rules which operation should be done first. Okay. Now I just listed here. Some of you may already know this. For example, let's look at example here, like this one. 16 integer division 9, integer division 3. So what will the result be? So there are two divisions. So which one should I do first? 9 by 3 first, then 16 by, well, 9 by 3 will be 3, then 16 by 3 will be, integer division will be 5. Should I do that first, or do 16 by 9 first, then do this? It turns out you go from left to right. Okay, if the same operator, then you go from left to right. So 16 by 1, 9 will be 1, and 1 by 3 will be 0. Okay, so 3 plus. Now, this is higher precedence. You see, I had said this is a higher precedence. So the highest precedent, this is higher than addition. So division is done before addition. Okay, that's why you need to know these rules. So addition will be done at last, at the end. So 3 plus 0 will be 3. You cannot do 3 plus 16, okay, right now, because this division is a higher precedence. It is done first. Now this is also illustration. 5 double 3 is 1, but 5 by 3 is, as I said, 1.6 is like that. Okay. Now this is modulo. So modulo is after division, what is left? Okay. So 5 modulo 3 is, after division I get answer is 1. Well, 1 plus 2 is a modulo. Now, so yeah, so if you want a hex representation, I think that I already discussed, so you can ignore this. Okay.